mentioned, I'm performing the life cycle assessment of the process that we have been describing today, the amine-based carbon capture, utilization, and storage with rotating packed bed reactors and with our solvent CDR max. So today we have already been discussing since the morning about policies. We have talked about carbon management and the need for CCUS. We will look into the difference between reduce, avoid, and remove carbon, because this is a very important concept for the life cycle assessment and the presentation of the results, our results. We have also looked during the previous sessions about the technology that we are developing and the contrast between the amine-based absorption that which are the columns, that this is already an established technology at the commercial scale, versus our technology, which is a scale up from TRL6. So we have presented these two technologies, and now that I believe everyone has a thorough understanding of what HyRecord project is about, I would like to connect all the dots between the policies, the economic part, and the technological part, how everything connects with the life cycle assessment and what we are trying to do with the bigger picture. So first of all, why CCUS? Well, here on the right, we can see a graph that represents how, with its corresponding uncertainties, of course, but how our world in data is predicting that our current policies are going to take us in terms of the global temperature increment to 2100. So according to the IPCC, to stay within the safe limit of 1.5 degrees Celsius of global warming, the estimates suggest some estimations, because there are several scenarios and pathways, but some estimations suggest that the global capture capacity should be 1.6 gigatons per year, rising to 7.6 in 2050. So the question to why CCUS is actually we need to remove, we need to capture and remove 2 billion to 10 billion tons of CO2. And we don't only need one technology, we need several technologies, and one of those technologies is CCU, and this is what we are doing with HyRecord. So this is why. As I mentioned before, there is a very important difference between reduced, avoided, and removed carbon, especially when presenting results for life cycle assessment, because sometimes when we see the results, when we try to compare the results, we see that there is maybe some misleading way of presenting results, or misunderstanding to perhaps push that the technology is emitting less than what actually it is emitting. So avoided CO2 is actually what we are doing with carbon capture. We are preventing the CO2 that is produced by an upstream process to reach the atmosphere. With HyRecord, we are also reducing the CO2 emissions, because we are implementing lots of intensification approaches to the process. So we are, in the process itself, reducing the CO2 that would be emitted if perhaps we were not using rotating packed beds or CDR max as a solvent. But we are not, and any CCUS technology is not having removal. So that is not a way to present results for this type of technologies in a life cycle assessment. So we are not going to do it that way. And why the need of the life cycle assessment in this project that we have been seeing since the morning? Because the life cycle assessment is a tool for quantifying the environmental performance of a product. And with HyRecord, we aim to have a very holistic approach about this. We have said already that the amine-based normal columns is an already established technology to capture the CO2. But when we are capturing the CO2 and preventing the CO2 to reach the atmosphere, perhaps we are shifting the environmental burden to another type of categories. We are affecting another type of perhaps water resources, minerals like precious minerals are becoming less. We are affecting those type of categories as well. So it's important to present the results not just in terms of how CO2 we are, how less CO2 we are emitting or how much we are avoiding, but also where the shift to other categories is going. And also, life cycle assessment is a very powerful tool that will allow us to compare in a very fair way, and I will discuss this more in the methodology, an emergent technology like ours, because we are in TRL6, with an established technology. Also, these type of processes have, for example, accumulation of hazardous components. Solvents is well known that introduce some more emissions, not necessarily CO2, but some other emissions to the environment. So we need to know and account for how much we are emitting in these categories as well with our projects. So the methodology that we are approaching, as we said, is holistic. So we decided to implement the recipe method. We will go with all the midpoint categories and the endpoint categories as well. Like in the next slides, I will present all the different scenarios and the different options that we are looking into. And the idea is to, when we will present these results, when we will publish the results, to do it in a way that is very useful for comparison, also for the literature and for the research community. That is, we want to present the results in a very disaggregated way as well. So because we have a lot of data within the project, we think that it is important to present very precise results with respect to all the data that we have for all the technologies and the different parts and all the scenarios. But at the same time, when we will be comparing our technology with the benchmark, of course, we are going to make a fair comparison and use the same type of data to compare the two systems. So in this case, we will have all this type of data presented. And we are also going to look into, we're also looking actually into prospective elements, because as we said, we are making a study on an emerging technology. So I believe you became acquainted already with this flow sheet already. But if you were paying attention here, there is a new section incorporated, which is the reclamation. As we said before, there is an introduction of hazardous components as well with this type of technologies, and we want to account for that as well. When we are making the assessment, it's important to compare both the operation and the construction phases. So with respect to the construction, all the data is there, and it's even obvious and pretty clear that rotating packed beds consume and utilizes way less resources compared to the normal columns. But we also need to account for the operation itself. And in our case, we are using a solvent which has a patent. So in order to really be able to present the results and to account for that, it's being very interesting. I think those will be, when we will present that, a very interesting also framework to perhaps help other projects that are conducting life cycle assessments on products where not all the molecules are known and everything. I hope we can provide some insights with respect to that as well. And we are working very closely with Carbon Clean as well in order to be able to present transparent results and also protect their patent. Yeah, so with respect to And with respect to connected with the results as well, so far, because the presentation of the life cycle assessment and also the techno-economic assessment that we will perform, it has to be presented at the end of the project. But we really think that if we collaborate and with the partners that presented before that are developing all these new integrations, we can provide insight. So we don't really want to wait until the end of the project to present the results. But yeah, it's a very hard work in progress, because you will see there is a lot of data that needs to be gathered. So first of all, we have the main flow sheet. The flow sheet also has some differences between what is the model, where like the model that we had and the operating plant, the way it will be. We also have different companies that will test where we will be getting pilot plant data from. We are testing the rotating pack beds first with MEA. Then the idea is to also get clear results with CDR Max. And of course, make a comparison as well with the same system, with the same functional unit, with the same capture targets, with the conventional process with MEA as well. So we developed this in our lab. Here is the person who developed it, in order to be able to really, as I said before, make a fair comparison. So we have this model as well. And I already incorporated the thermal integration. And it will be possible as well, and very interesting, if we can also evaluate a corrosion mitigation on the steel, because we are utilizing a lot of steel in our process. So if the steel can have different sources, or we can get perhaps a more typical steel with maybe some enhancement that will reduce the environmental impact and the cost. So perhaps we'll be able to look into that as well. Besides the model that are provided by the partners, we are also developing offline models, as for example, the reclamation. So this is an offline model that we developed ourselves. This is the design equation. And this is in order to estimate the missing solvent, because the solvent is not only provided in the beginning of the operation, but there are some losses during the operation. So we need to account for that. As we said, the solvent is incorporating some hazardous components as well. So it's important to take this into consideration. Also in our group, we are working with developing our wastewater treatment. So all these attachments are offline, but will be incorporated in the LCA as well. And well, so far we have, if you have noticed, we have been talking about cradle to gate boundaries, but within the project panels, I have already included the SERF, as was mentioned before, is also evaluating the transportation routes, because we are the plants that we are using, that we are working with, are all in Greece. So there is a cluster, there is a possibility of combining and taking advantage of the location of where the plants are, in order to evaluate the utilization routes, and also in order to combine their upstream processes with utilization routes. So this will be done as well in the process. And as I mentioned before, we are also willing to incorporate prospective and dynamic elements in the system. Why the prospective elements? well, once again, because we are considering an emergent technology. If you can see here, the contrast between the dimension is very notorious. And we all know that if everything goes well with respect to policies, things in the near future, when this technology will be deployed and implemented, will be different than now. So it's important for us to place ourselves also in the future when we are making the environmental assessment to better understand what will be the background, what will be the surrounding of our technology in that moment, because the impact might not be the same. So we need to look into that. And why dynamic LCA? Because AUTH has developed a very specific or a very comprehensive dynamic model. The operation we know in the companies is not always is not continuous. There are shutdowns for maintenance. There are also shutdowns with respect to the carbon capture section if the energy is too expensive. So sometimes the electricity goes up, and the company might decide not to capture CO2 in that moment. So I will move here first. So it is very interesting to consider the dynamism of the process. Of course, there are different types of dynamic life cycle assessment. We can consider dynamism in the characterization factors, dynamism with the supply chain. But since we have the dynamic representation of the capture process, we are interested in combining this with the particular energy distribution for Greece, for example. So in this case, this is how it looks, the energy distribution in the month of August. There is some solar energy, for example, here, and this is mostly the fossil energy. And this is a very important parameter in our technology, the electricity, because as we saw before, we are also incorporating and integrating the heat pumps. So we might be able to completely replace the necessary steam with the heat pumps. So the electricity in our case, and also with respect to the preliminary results that we have, is the most important inventory and the most important source of emissions in our process. And the same goes for the prospective part, because now the distribution for a particular day looks like this. I should have put what is exactly my byte. I'm sorry. I will update that when I will upload the slides to be exactly sure what's exactly there. But we also expect that the shares of renewable energy will be bigger in the future. So the impact will be less, and both for the dynamic case and for the prospective case in the future. So this is how the bigger picture looks. This is what we will look a comprehensive analysis, where when we will combine all the data that we have for the models from the partners, especially when we will be able to complete the assessment with the accurate data for the solvent, which will make the difference. With these prospective elements that we have been mentioning before. So this is, I want to say, our very preliminary results, was just to show in a very, very, very simple way how the difference between the conventional columns with their rotating packed beds looks like. In this case, we are using, I had the data for MEA for both, and not very much data for the operation. So this is mostly the construction part. So as I said, is very preliminary, and if someone is listening, or if someone is here that is interested in doing the masters with our group, we have many opening positions. Yeah, so this is how it looks so far. We, as I said before, and I will close with this, we intend to present all these results in a very comprehensive and disaggregated form so that they can be further compared with all the research that's going on in this line and in this direction. So yeah, these are the sources. And finally, please stay tuned, follow High Record. And as I said before, this is our QR code if someone in the audience or someone who will listen to the presentation afterwards when we will be uploaded, or you want to join the team. Thank you so much.